Today we're doing section 6.3, and this section is about polar coordinates. So we're going to talk about plotting polar coordinates today and multiple representation of coordinates. So to plot a polar coordinate, first step is you graph the ray, and actually let me show you. So a polar coordinate looks like this, r comma theta. So notice it has the same appearance as a point x and y, but it has a different representation. So r is your radius, and the theta represents an angle. So second step is to draw a ray. So draw a ray at given angle. And third step is to plot the point, whatever the corresponding radius is. If your r is positive, you are on the ray. If r is less than 0, you're going away from the ray. So we're going to do 3 examples just to kind of get the hang of this. So I'm going to change my background on my screen to be polar paper so you can kind of get a better understanding of this. So for our first example, the coordinate is 2, 135 degrees. So first thing we do, notice the thicker line in the middle going up and down represents like your x and y axis. So I figure out where 135 degrees would fall. So I know this right here is 90. And I know over here is 180. So 135 is actually going to fall exactly halfway in between quadrant 2. So there's my ray. And now, because the radius is 2, that means I'm going with the ray. And notice all these circles, so all these little circles represent radius of 1, radius of 2, radius of 3, and so on. So if I go to a radius of 2, my dot will be right there. And that point is going to be our final answer. So there's your coordinate. So let's try another one. So example, now the coordinate is -3 and a 3 pi over 2. So notice you could be in radians, you could be in degrees. It just depends on what information is given to you. So 3 pi over 2, I know goes straight down. So here's my ray. And because my radius is 3, it's a -3, regardless, I'm still going to be a circle, right 3 circles away, but because it's negative, I go in the opposite direction. So I have 1, 2, 3 circles, and I go the exact opposite direction of where my ray is pointing. So there's our final answer for that coordinate. So let's try one more. So for our final example, the coordinate is -1 and a negative pi over 4. So we know negative angles go the opposite direction, and a negative pi over 4 is exactly halfway in the middle of a quadrant. So negative pi over 4 is going to be right here in quadrant 4. And my radius is a -1, so I'm going to go one circle. And because I'm in the negative direction, I go the exact opposite way. So I'm going to be kind of going where a -3 pi over 4 would be pointing. And I go a radius of 1. So that would be the final answer of that coordinate right there. So we're going to do some more practice on that tomorrow. Next thing I would like to go over is multiple representations of a coordinate. to find multiple representation of points, it's pretty basic. You just follow two kind of steps. So the one possibility is that you add 2 pi and you keep r the same. The second scenario is if you want a different r, so you change r to negative r, and then you only add pi to your angle. So that's the two possibilities, and essentially what this means is I'm trying to come up with two different coordinates or three different coordinates that would all end up looking exactly the same on the picture. It's just a different way to write it. Kind of the idea of like a coterminal angle. If I go around and around and around, it always falls in the same spot. It's just a revolution separates it. So that's the same kind of idea here. So for our first example like this, let me change my paper. So our example is they give you the coordinate 2 and a pi over 3. And there's 3 scenarios they want you to meet. So for the first one, for letter A, they want r to be positive. And they want the angle to be between 2 pi and 4 pi. So to kind of go about this one, we'll do this one graphically, and the next ones we'll just kind of use the formula. So we know pi over 3 is going to be exactly halfway between pi over 4, and pi over 4 is the halfway mark, and the pi over 2. So pi over 3 is right here, exactly halfway in between. And let's see. I want my r to remain positive, but I want my angle to be between 2 pi and 4 pi. So first we're going to plot the point. So when r is 2, 1, 2, I'm 2 units on my circle, and I want the angle to be bigger. So what essentially I need to do is go 1 full revolution around and figure out what that angle would be, and then I have the same coordinate. So to do that, I keep r the same, and I have to add 2 pi to that. Now in order to add these, I need to have common denominators, so I'd multiply this by 3, top and bottom. So I'll have pi over 3 plus 6 pi over 3. So the second angle would be a 7 pi over 3. So this original coordinate is the same as saying 2 and a 7 pi over 3. It's just one full revolution around. So we know, like, if we were to go around, this would be 3 pi over 3. And I could keep going around, so this would be a 7 pi over 3. And notice the dot falls in the same spot, which is our ultimate goal. So let's try another one, but without the picture, just kind of doing it formula. So same coordinate, we'll still do 2 and pi over 3, but now the second scenario I want us is r is negative, and I want my angle between 0 and 2 pi. So if you go back to what I said 2 slides ago, I said if r is to become opposite sign, then we add pi. So my r is going to become negative, so I make it a negative r. Now I have to take my angle and I have to add pi to it. Now in order to add pi, again, we need common denominator, so I'd multiply by 3. So my coordinate would become negative 2. This would be a 3 pi over 3. So when I add 1 pi over 3, we get 4 pi over 3. So if I were to graph this, I would be in the exact same spot. And to kind of prove it to you, let me go back a screen. So 4 pi over 3, we know that here's 3 pi over 3, so 4 pi over 3 is going to be down here, going this direction. And now if the r is negative, I'd go 2 units away, and notice I'd fall in the same exact spot. So it maps us to the same spot. So one last one that we're going to go over is, again, 2 and then pi over 3. But the final scenario I want is r to be positive, and I want my angle to be between negative 2 pi and 0. So now I'm going to keep my r positive. I take this pi over 3, and since it's between negative pi over 2 pi, and 0, I'm going to subtract 2 pi. And again, we multiply by 3. So I'll get 2, and this will be pi over 3 minus 6 pi over 3. So 2 comma 5 pi over 3. So this information, again, if I were to plot this, would still match. Sorry, this would be a negative 5 pi over 3. This would still plot me in that same exact spot. So that's all for today.